Hi, today we're going to be doing sequences, but this time it's not going to be an arithmetic or geometric. It's going to involve still a list of numbers that are following a pattern. If I go back to the use what you know, we can try to figure out the pattern, what's going on. On this particular problem, let's see. It looks like first we are adding 2. Then we're adding 3, then we're adding 4. So then we can figure out what the pattern is. It's adding 5, then adding 6, adding 7, and adding 8. Now this will be very tedious because if I want to get to the 100th, I would have to keep on doing the pattern or finding the pattern out. On the next one, again, following a pattern. Let's see. First it's add 1, add 2, add 3, and therefore we can probably figure out the rest. Oops. Okay, and if we look at the last one, let's see what's happening. Well, we can always try adding first. Adding 4, adding 6, adding 8, and then it looks like it's adding even numbers at this point. And etc. All right, so these are following a pattern, but not an arithmetic or geometric. We could generate this pattern using what's called a recursive formula. So a recursive formula is a formula to generate a sequence where the next term is dependent on the term before it. All right, and then our similar vocab that we've seen before. A sub 1 is the first term. A sub 2 is the second term. A sub n means the nth term. So those three we've seen before. And then you are going to see two other ones. One of them is in our vocab, A sub n minus 1. And again, I want to stress that subscripts are like adjectives. So if this is the nth term, then n minus 1, the relationship would be that that was the previous term. And that's exactly what it is. It's the term before the nth term. Okay, so looking at example 1, A sub 1 is 15. So this is telling you that the first term of the sequence that we're going to generate is 15. So now we have to find the next 4 terms. All right, this right here tells us how to generate the patterns starting from the first. So on these type of sequences, you must have the first term listed. Otherwise, there's no way to figure out what the sequence is. All right, I'm going to first start off by showing you the long way. The long way would be to say A sub 2 is equal to, right here, I'm going to follow the pattern. That means it's going to be A sub 2 minus 1 plus 6 more. And if I simplify that, that's A sub 1 plus 6 more. And A sub 1 right here is our 15. So 15 plus 6 which is 21. All right, so now we know it's 15 and we know it's 21. Now we have to figure out the next one. So a sub 3, if I just follow the pattern, a sub 3 is equal to a sub 3 minus 1 plus 6 more. All right, so let me stop a second. Remember that the ends have to be a match. So those again are the end numbers. Also, please keep in mind that subscripts are not a mathematical operation. So when I simplify that and say A2, that does not mean take the A number and multiply it by 2. That means the second term plus 6 more. And the second term we got over here, A2 is 21. So it's 21 plus 6, which is 27. Okay, now we have to find the next term, but you might already see what the pattern is. You can tell that the first one added 6 to get to the next one was adding 6. So we could probably figure out the next term is going to be 33. I personally like to do recursives by talking in actual words what's happening. So I'm going to do this. The next term is equal to, that's what this means. The term number you want is equal to n minus 1 from our definition means the term before it. Plus 6 more. So if you can read it like that, I don't have to go through all the notations and all the symbols. I know it's 15 for A1. I know A2 is the prior term 15 plus 6 more. I know A3 is the prior term plus 6 more. And then I know A4 is the prior term plus 6 more. So we can do it with the symbols, looks a little cumbersome and tedious, or we can just do it by actually understanding what the formula is telling us to do. All right, so we'll try it with this one. A1 is 5. Okay, this is saying that the term the next term is equal to the previous term plus the term number you're on. So that n and that n match. Now this is a big N, not a subscript. That means we are in fact going to add what the term number is. So we'll write it in words. So the next term is equal to the term before it plus the term number it is at. So A2 equals the term before it plus the term number that this number is at, and we are at term 2. So that means we're going to add 2 more to that, and that's 7. A3 equals, again, the term before it, which is now 7, plus the term number you're at, which is the third term. Lastly, A4 equals the previous term plus the term number you're at, which is now we're on term 4. Okay, so our numbers are 5, 7, 10, 14. If you want to just compare it to what it would look like if we had to actually just use the notation, I'll do the first couple. A1 is 5. So A2 would equal A sub 2 minus 1 plus 2. That simplifies to A1 plus 2. And then you fill in A1 for that guy, which is back here at 5. Then I'll try one more. A3 would be A sub 3 minus 1 plus n, which is 3. So there's my n's. And again, I'm doing just that with the formula. Those are your n's. You fill those in. That's equal to A sub 2 plus 3. And A sub 2 equals, well, back here, equals 7. And then we'd have to still do A4. Now, it's your choice which way you want to do it. If you can understand how to word it, then you don't have to show anything but what I did over here. If you're having trouble with that, you can always fill in the numbers and then simplify, and you'll be directed on what to do, because after you fill it in, you plug in A1 right there, and you plug in your n right there. Okay, I'm going to stick with the first method with just using the wording. So the next one, example 3, A sub 1 equals 9. Okay, so A sub n, the next term is equal to 2 times, then that's the previous term, and then we're going to subtract now. So I'll say 2 times the previous term, then subtract the term number. Okay, so A sub 2 then would be 2 times the previous term, and then minus off the term number, and we're on term number 2. So A sub 3 will equal 2 times the previous term minus the term number, which we're on 3 now. And then A sub 4, because we're trying to find the first 4, would equal 2 times the previous term minus term number 4. Okay, so that's the shortcut way. Again, I'll just show you one last time what it would look like if I wanted to fill in. A1 equals 9. So A sub 2 would equal 2 times A sub 2 minus 1 minus 2. Just filling in for the n's. Then what you do is you simplify. And again, this means the first term. Yeah, I'll try this one more time and not finish the fourth one. A sub 3 would mean 2 times A sub 3 minus 1 minus the n number, which again is 3. Those are my n numbers. This right here reduces to A2. And then A sub 2, we just did. A sub 2 is 16. Etc. Okay, again, I prefer this. If you can read the formula and you understand what it's saying, then that is enough work that I showed on the left. So I'll only do it the shortcut way this time. So for this one, we have to find the next 8 numbers. So we have A sub 1 is 0. A sub 2 is 1. Okay, the next term is equal to the term before it plus, and then we have this new guy. You might be able to figure out what that is. That says n minus 2. So that means it's 2 terms before it. So if I make this in simpler words, the next term is equal to the sum of the 2 prior terms. Right? Because this was the term before it, and that was 2 terms before it. So that's the sum of the 2 prior terms. So if I want to do a sub 3, the 2 prior terms were 0 and 1. So that would be 0 plus 1. Or you could do 1 plus 0. A sub 4 then would equal the 2 prior terms. That would be the A3 and the A2 terms. So that would be 1 plus 1, which is 2. Then a sub 5 would equal the 2 prior terms, which would be A4 and A3. So that's 2 plus 1, which is 3. A6 would equal the sum of the 2 prior terms. So that would be 3 plus 2. A7, the 2 prior terms. And then lastly, A8, the 2 prior terms. So we have 0, 1, 1, 2, 3, 5, 8, and 13. This is actually a very famous sequence. It is called the Fibonacci sequence. You can try to Google it and find out some interesting stuff about it if you like. It happens a lot in nature. That was why I put the first picture in on our notes. A lot of things in nature will follow the pattern of 1, 1, 2, 3. I guess pineapples follow that pattern. There's musical notes that follow that pattern. It's involved in the golden ratio, so it's a pretty interesting sequence if you'd like to research that.